Good afternoon, Grade 8 learners. This is your School on the Air in Mathematics 8. I am Teacher Nancy B. Pineda of Benigno S. Aquino National High School, your Grade 8 Regio teacher. Are you excited to graph linear equations? But before we start, kindly prepare your self-learning module or your book, your pen, and paper to write your solutions and answers as we progress with our discussion. Also, look for a place in your home where you feel comfortable and safe. And most importantly, prepare yourself to watch and listen carefully. In today's lesson, I will be guiding you in answering your Week 6 lessons of the first quarter of Mathematics 8 with the topics on linear equation in two variables. At the end of this lesson, you are expected to, number 1, write the linear equation ax plus by is equal to c in the form y is equal to mx plus b and vice versa. Number 2, graphs a linear equation given any 2 points, the x and y intercepts, and the slope and its intercepts. Last week, you have learned how to plot points on the Cartesian plane. Now, let's check your prior knowledge. Get a piece of paper and pen, watch and listen carefully. How do we plot points or coordinates on the Cartesian plane? Consider the point which has coordinates 4, -2. Do you have your answers? Let's check. Remember to start at the origin. The first number tells you how far to move along the x-axis. So the 4 in point 4, -2 tells us that we need to move 4 units to the right. The second number tells you how far to move along the y-axis, up or down. The -2 in 4, -2 tells us that we need to move 2 units downward. So there is the point of 4, -2. Remember that if the x-coordinate is positive, count to the right. If the x-coordinate is negative, count to the left. If the y-coordinate is positive, count upwards. And if the y-coordinate is negative, count downwards. I hope I refreshed your knowledge. Later on, we will be using the Cartesian plane again to graph linear equations. Now, let us proceed to our new lesson. We have linear equations in two variables. Linear equations in two variables may be written in two forms. We have the standard form and the SlopeIntercept form. So our first topic is rewriting linear equations in standard form into SlopeIntercept form and vice versa. Standard form may be written in the form of ax plus by is equal to c, where a, b, and c are real numbers. A and b are not both 0. And SlopeIntercept form may be written in the form of y is equal to mx plus b, where m is the slope and b is the y-intercept. M and b are real numbers. For our example number 1, Rewrite the linear equation 3x minus 5y is equal to 10 into the form y is equal to mx plus b. First, rewrite the given 3x minus 5y is equal to 10. And then, subtract 3x from both sides, so we will have 3x plus negative 3x minus 5y is equal to 10 plus negative 3x. And then, simplify. We'll have negative 5y is equal to negative 3x plus 10. And then, divide both sides by negative 5 to eliminate the coefficient of y. So the result will be y is equal to 3 over 5x minus 2. Now, in example number 2, we will rewrite linear in the form of y equals mx plus b equations into the form of ax plus by equals c. Here is the question for example number 2. How do we rewrite the equation y equals 1/2 x plus 3 in the form ax plus by equals c? Again, how do we rewrite the equation y equals 1/2 x plus 3 in the form ax plus by equals c? Here is the solution. First, rewrite the given y equals 1/2 x plus 3. Then, by using the multiplication property of equality, multiply 2 from both sides to eliminate the denominator 2. It will be 2 times y equals 2 quantity 1/2 x plus 3. And then, simplify, we will get 2y equals x plus 6. We get x plus 6 by multiplying 2 to quantity 1/2 x plus 3. 2 times 1 is 2 divided by 2, that is 1 x or x, and then multiply 2 times 3, that is equal to 6. Just simplify, we will get 2y equals x plus 6. Next, by using the addition property of equality, add negative x from both sides of the equation, and then simplify. Again, by using the addition property of equality, add negative x from both sides of the equation, and then simplify. We now have negative x plus 2y equals 6. Negative x plus 2y equals 6 is in standard form, but we can also make our first term positive by multiplying the whole equation by negative 1 to make the first term positive. Hence, the standard form of y equals 1/2 x plus 3 is x minus 2y equals negative 6. We may now proceed to our next topic, which is graphing linear equations using any 2 points. Here are the steps in graphing linear equations in two variables using 2 points. Step 1. Assign two values for x. Remember that x is any real number. Second step. Solve the values of y by substituting the assigned values of x in the equation. Third step. Plot the 2 points or the solutions of the equation in the rectangular coordinate system, or what we call the Cartesian plane. And then finally, connect the 2 points to form a straight line. For our example number 1, graph the linear equation in two variables y equals x plus 2 using 2 points. Again, graph the linear equation in two variables y equals x plus 2 using 2 points. Here is the solution. Step 1. Assign two values for x. Remember, you have to choose any real number for your value of x. So for our example, let x equals 1 and let x equals negative 2. In step 2, using the values of x obtained in step 1, solve the values of y by substituting the assigned values of x in the equation. So we have, if x equals 1, then y equals x plus 2. Then, substitute the value of x by 1, we have y equals 1 plus 2. 1 plus 2 is equal to 3. Therefore, the value of y, if x is equal to 1, is equal to 3. Hence, the first point or the solution is 0.13. Then, use the second value of x, which is negative 2, to obtain the second value of y for our second point. So, if x is equal to negative 2, then y equals x plus 2. Substitute the value of x, which is negative 2, from the equation. It will be y equals negative 2 plus 2. Negative 2 plus 2 is equal to 0. Therefore, the second value of y is equal to 0. Hence, the second point for the linear equation y equals x plus 2, if x is equal to negative 2, is -2, 0. Step 3. Plot the 2 points we obtained in step 2 in the rectangular coordinate system, or what we call the Cartesian plane. From the step 2, we obtained points 1, 3, and -2, 0. First, plot the point 1, 3. Next, plot the second point with coordinates -2, 0. And for our last step, connect the 2 points to form a straight line. So we now have the graph of y equals x plus 2. We may now proceed to our next lesson, which is graphing linear equations using the x and y intercepts. The x-intercept and the y-intercept. The x-intercept of the line is the value of x when y is equal to 0. It is the abscissa of the coordinate of the point A, 0, where the graph intersects the x-axis, while the y-intercept of the line is the value of y when x is 0. It is the ordinate of the coordinate of the point 0, b, where the graph intersects the y-axis. The next method of graphing makes use of the intercepts. Take note that the y-coordinate of any x-intercept will always be 0, and the x-coordinate of any y-intercept will always be 0. Here are the steps in graphing linear equations in two variables using x-intercept and y-intercept. Step 1. Solve for x-intercept by letting y equal 0 to have a point A, 0. Step 2. Solve for y-intercept by letting x equal 0 to have a point 0, B. Step 3. Plot the 2 points on the Cartesian plane. And step 4. Connect the 2 points to form a straight line. For our example, graph the equation using its x and y intercepts. The equation is 4x minus 3y equals 12. Again, the equation is 4x minus 3y equals 12. Here is the solution. Step 1. Solve for x-intercept by letting y equal 0 to have a point A, 0. To find the x-intercept, let y equals 0. First, rewrite the given 4x minus 3y equals 12. Then, substitute the value of y, which is 0, to the equation. We will get 4x minus 3 times 0 equals 12. Then, 4x minus 3 times 0, which is 0, equals 12, or 4x minus 0 equals 12. And then, divide both sides by 4 to get the value of x. 4x divided by 4 is equal to x, and 12 divided by 4 is equal to 3. Therefore, x is equal to 3, and 3 is our x-intercept. Hence, the first point has coordinates 3, 0. Step 2. Solve for y-intercept by letting x equal 0 to have a point 0, B. To find the y-intercept, let x equal 0. Again, rewrite the equation 4x minus 3y equals 12. Then, substitute the value of x, which is 0, to our original equation. We have 4 times 0 minus 3y equals 12. 4 times 0 is equal to 0 minus 3y equals 12. To get the value of y, divide both sides by negative 3. Negative 3y divided by negative 3 is equal to y. And 12 divided by negative 3 is equal to negative 4. Now, the y-intercept of 4x minus 3y equals 12 is negative 4. Hence, the second point has coordinates 0, negative 4. Now, plot the 2 points or our x and y intercepts on the Cartesian plane. Plot 3, 0. 3, 0 is located on the x-axis of the Cartesian plane, while 0, negative 4 is located at the y-axis of our Cartesian plane. So we now have the graph of 4x minus 3y equals 12 using the x and y intercepts. Our next topic is about graphing linear equations using slope and y-intercept. But before that, let us review the slope of a line. The slope of a line through points x sub 1, y sub 1, and x sub 2, y sub 2 is given by the formula m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 is also equal to the rise over run. Recall that rise means how many units you move up if the rise is positive or down if the rise is negative. On the other hand, run means how far left or right you move from point to point. If your run is positive, you will move units to the right. If your run is negative, you will move units to the left. We also discussed last week the 4 types of slope. First, a line with a positive slope rises from left to right. The greater the slope, the steeper the line rises. Second, lines with negative slopes fall from left to right. Third, a horizontal line has 0 slope. And the fourth type is a vertical line which has no slope or the slope is undefined. The SlopeIntercept form is written as y equals mx plus b, where m is the slope or the rise over run, and b is the y-intercept, where the line crosses the y-axis. A linear equation written in the form y equals mx plus b is in SlopeIntercept form. The slope is m and the y-intercept is 0, b. To graph an equation in SlopeIntercept form, we will follow these following steps. Number 1, write the equation in the form y equals mx plus b. Then identify m and b. If the equation is not written in the form y equals mx plus b, you have to rewrite it first in the SlopeIntercept form and then identify m and b. Step 2. Plot the y-intercept first. Step 3. Starting from the y-intercept, find another point on the line using the slope, use the rise, and run in locating a second point. Step 4. Draw the line through 0b and the point located using the slope by connecting the 2 points. Example number 1. Graph the line y equals negative 3 over 2x plus 6 using its slope and y-intercept. Again, graph the line with equation y equals negative 3 over 2x plus 6 using its slope and y-intercept. The equation y equals negative 3 over 2x plus 6 is in the form of y equals mx plus b, or the SlopeIntercept form. So, we have to identify first the m and b. So, m is equal to negative 3 over 2 and b is equal to 6. Step 2. Plot the y-intercept. We have 0, 6. 0, 6 is located at the y-axis of our Cartesian plane. Step 3. The slope is negative 3 over 2. Notice that our slope is negative. Remember that if the slope is negative, the line rises from right to left, or it falls from left to right. To plot the second point, in step 4, start at the point 0, 6. From our first point 0, 6, count 3 units downward since the slope is negative. So we have to count 3 units downward from the first point 0, 6 and 2 units to the right to locate a second point on the line. The point 2, 3 is our second point. Step 5. Next, draw the line through 0, 6, and 2, 3. We now have the graph of y equals negative 3 over 2x plus 6. As you can see, the line falls from left to right since the slope given is negative. For our second example, graph the line 2x minus 3y equals 3 using its slope and y-intercept. First, rewrite the equation in slope-intercept form. Why? Because 2x minus 3y equals 3 is in the form ax plus by equals c. So we have to rewrite the equation in slope-intercept form. Using our knowledge in rewriting equations in the form ax plus by equals c into y equals mx plus b, first, rewrite the original equation 2x minus 3y equals 3. Then, using the addition property of equality, add negative 2x on both sides of the equation. We will get 3y equals 2x minus 3. Then simplify by dividing both sides of the equation by 3. The result is y equals 2 over 3x minus 1. And then identify the slope m and the y-intercept b. The m is equal to 2 over 3 and b is equal to negative 1. Second, plot the first point by using the y-intercept with coordinates 0, negative 1. 0, negative 1 is located at the y-axis of the Cartesian plane. Now, by using the slope 2 over 3, start at the point 0, negative 1, count 2 units upward since the rise is positive, and 3 units to the right to locate a second point on the line. We now have 2 points. The first point is our y-intercept with coordinates 0, negative 1, and the second point has coordinates 3, 1. And for our last step, draw the line through 0, negative 1, and 3, 1. If you still want to get the third point of the equation 2x minus 3y equals 3, from 3, 1, move 2 units up and 3 units to the right. We now have the third point with coordinates 6, 3. Observe that the third point 6, 3 is also part of the same line with points 0, negative 1 and point 3, 1. That's all for now. You did great watching and listening. I hope you have learned something from our lesson today. See you in our next episode on School on the Air. Keep safe and God bless us all.